Hello dear students, in previous video we were discussing about the spherical mirrors. Spherical mirror is a part of a hollow sphere whose the one side is reflecting and the other side is opaque. And we know that there are two types of spherical mirrors. They are nothing but first one is the concave mirror. Concave mirror. And second one is the convex mirror. These are the two types of the spherical mirror. Now let us first discuss about the concave mirror. Then what do we mean by concave mirror? Concave mirror is a part of a hollow sphere and whose the reflecting surface is towards the center. Then that type of the mirrors are called as concave mirrors. So concave mirror is nothing but it is a part of the hollow sphere whose the reflecting surface towards the center of curvature. That is called as a concave mirror. Then how we represent the concave mirror? We know that in general spherical mirrors are the part of the hollow sphere. Assume that this is an sphere and a sphere has one center and this is the center of the sphere. And we know that the spherical mirrors are the part of the hollow sphere. If I take one part of this sphere, then I get this is the one part of the hollow sphere. If I separate this one, I will get the shape like this. This is the one part of the hollow sphere. And this is the also called as a curvature of the sphere. And the center is this is the center for this curvature. So I am taking the center here. This is the center. Okay. And this is the shape of the concave mirror. And here by definition concave mirror is a mirror whose the reflecting surface is towards the center of the curvature. Okay, that means see here, this is the shape of the concave mirror and it has a reflecting surface and its reflecting surface should be towards the center. That means the face of the reflecting surface is towards the center of the curvature. So that this is the reflecting surface. This is the reflecting surface and another surface is opaque. That means it is the non-reflecting surface or it is the painted surface. So this is the representation of a concave mirror. Okay, that means here the reflecting surface is towards the center of the curvature and the other surface is painted or opaque. So like this we are representing the concave mirror. Now we will discuss some parts or some terms which is related to the concave mirror. We are using one term that is nothing but a pole. We are using the one term pole in the case of the spherical mirrors. Then what do you mean by pole? The pole is nothing but it is the geometric center of the concave mirror. Pole is nothing but a geometric center of the concave mirror. That is called as a pole. That means see here, this is the concave mirror. If I take exactly the center of this concave mirror, then that center is called as a pole of that concave mirror. So pole is nothing but it is the geometric center of the concave mirror, or exactly the center of the concave mirror is called as a pole of the concave mirror. And another term we are using here, radius of curvature of a concave mirror. Radius of curvature of a concave mirror. Then what is by radius of curvature of a concave mirror? We know that the concave mirror is nothing but it is the part of the hollow sphere. That means if I extend this one, I am getting one sphere, right? I am getting one sphere means that sphere has one particular radius, right? So how to represent the radius? So radius of the concave mirror is nothing but it is the radius of the sphere to which mirror forms a part, that is called as radius of a curvature. Radius of curvature is nothing but it is the radius of the sphere, radius of the sphere of which a mirror form a part, mirror form a part. That means a concave mirror forming part, that is called as a radius of a curvature or radius of the concave mirror. How to take the radius of the concave mirror? We know that in general we are taking the radius from the center of the sphere or center of the circle to the curvature, any point on the curvature. Here also I am taking, it is the distance from center to the pole, or you can call the radius of curvature of the concave mirror is nothing but it is the distance from pole to the center. So this is the radius of a curvature or radius of the concave mirror. Another term we are using in the case of concave mirror is that is the principal axis. Then what do you mean by principal axis? Principal axis is the line joining the pole and the center of the concave mirror. That is called as a principal axis. So principal axis is nothing but it is the line joining the pole, and here pole also called as a optic center. We can call pole also as a optic center. The line joining the pole or optic center and the center of the concave mirror. That is called as the principal axis of the concave mirror. So here we already drawn one line from pole to the center. Here also we are telling that in the case of principal axis also we are telling that it is the line joining the pole and the center of the concave mirror. Then what is the meaning of that? See here, the principal axis is nothing but here if you take this as a concave mirror, I am drawing one line from pole to the center, and this line has no any limit. I can extend this length from pole to the center, and you can take any length for the principal axis, and that should pass from center and pole of the concave mirror. That is called as a principal axis. That is one of the term we are using in the case of a concave mirror. And another term we are using, that is the principal focus. Principal focus. Then what do you mean by principal focus? Principal focus is nothing but when the parallel or paraxial rays are incident on the concave mirror, after reflection, the incident ray, all the incident rays will meet at a point on the principal axis. That point is called as a principal focus of the concave mirror. So principal focus is nothing but when parallel rays are incident on a reflecting surface of the concave mirror. After reflection, they meet at a point on the principal axis. Then that point is called as a principal focus. Now let us see what is the meaning of a principal focus. See here, I am going to incident rays of light. That is a paraxial rays. Paraxial rays means, see here, these rays are exactly parallel to the principal axis. Then that kind of rays, incident rays, are called as a paraxial rays or parallel rays. And all these rays are parallel to each other. So here I am considering two rays of light incidenting to the reflecting surface of the concave mirror, and both the rays are parallel to each other, and both the rays also parallel to the principal axis. When I incident parallel rays to the reflecting surface of the concave mirror, after hitting to the surface, it will reflect back, it will return back, and it will meet some point on the principal axis. So this is in the case of first ray of light, and after hitting to the reflecting surface, the second ray of light also bounces back, and when it bounces back, it will meet some point on the principal axis. That point is the common point in which the first incident ray meets. That is the common point here. That means here this common point on this, that means the common point in which both the ray of light meets after the reflection on the principal axis. That is called as a principal focus. This is the principal focus of the concave mirror. That is the another term in which we are using in the case of a concave mirror. The next term in which we are using in the case of concave mirror is focal length. Focal length. This is very important term. Focal length. Then what do we mean by focal length? Focal length is nothing but it is the distance from the pole to the focus of the concave mirror. Then it is called as a focal length. Distance from pole or optic center. Pole is also called as optic center. Distance from pole to the focus of the concave mirror. Concave mirror is called as the focal length. That means distance from pole to the focus. This distance, that is called as a focal length of the concave mirror. Okay, that is the another term we are using. And here also we are observing the reflection, right? When we incident a parallel rays on a reflecting surface of the concave mirror, we are observing the reflection when the incident ray hitting to the reflecting surface. Then we want to know the angle of incidence and the angle of reflection. To know the angle of incidence and angle of reflection, we require one normal. We already studied it in the case of a loss of a reflection, right? So we need one normal. Then how to draw a normal in the case of the concave mirror? Now let us see what is the meaning of normal in the case of a concave mirror. Normal. So normal is nothing but normal to the concave mirror. Normal to the concave mirror at any point is the line join that point to the center. Then it is called as a normal of the concave mirror. So normal of the concave mirror is a normal to the concave mirror at any point is the line joining that point to the center. Then how to draw a normal in the case of the concave mirror? Let us see the normal in the case of concave mirror. Here I am considering concave mirror. This is a concave mirror, and it has one geometric center. That geometric center is nothing but the pole, and it has a center. The line which is passing through the center and the pole, that is called as a principal axis. This is the principal axis. Now I am going to incident a ray of light. So this is the incidenting ray of light. When it is hitting to the reflecting surface, it will bounce us back like this. It will bounce us back like this. So this is an incident ray, and this is an reflected ray. According to law of reflection, we know that the angle of incidence is equal to the angle of reflection. Okay, so wherever the reflection takes place, then angle of incidence should be equal to the angle of reflection. To know the angle of incidence and angle of reflection, we have to draw on a normal. So according to the normal, so normal to the concave mirror is nothing but it is the line we are taking from the point at which the incident ray and reflected ray meet on the surface. On surface of the reflecting surface, meet on the reflecting surface. From that point we have to draw a line, okay, like this, and that line should pass through the center. Okay, that line should pass through the center of the concave mirror. Then it is called as a normal. This is a normal. Using this normal, we can calculate the angle of incidence like this. So this is the angle of incidence. The angle between incident ray and normal. This dotted line is the normal. And the angle of reflection is nothing but the angle between the reflected ray and the normal. So this is the angle of reflection. Like that, we are drawing the normal in the case of a concave mirror. So normal we can draw it like this. We are taking a normal from a point in which the incident ray and reflected ray meet on the surface. From that point, we have to draw one line, and that line should pass through the center, and that line is called as a normal. That is about normal of the concave mirror. Now let us see how the reflection takes place at a concave mirror. See here, I am first considering concave mirror. So this is a concave mirror. This is the pole or optic center of the concave mirror, and it has one center. This is the center of curvature, and the line which is passing through the center and the pole, that is a principal axis, and principal axis has no any particular distance. Now assume that this is an focus, principal focus of the concave mirror. Okay, if I incident a ray of light, along the principal focus like this, I am incidenting light along the principal focus, then it will hit to the reflecting surface of the concave mirror. After hitting to the surface of the concave mirror, reflecting surface of the concave mirror, it will bounces back. But how it bounces back? So it bounces back like this. That means the reflected ray is always parallel to the principal axis. This is the one case in which we are observing at a concave mirror. So when we incident a ray of light along the principal focus, and after hitting to the reflecting surface, that incident ray will reflect back or bounces back. That reflected ray is always parallel to the principal axis. That is the one case of reflection. And another case we will observe that suppose that if I incident a ray of light along the center of the concave mirror, that means here again I am considering a concave mirror. This is a concave mirror and this is the principal axis. Assume that this is the pole and this is the center. Okay. Now I am going to incident a ray of light along the center like this. So this is the incident light which is incidenting along the center. And when the incident light hitting to the center, after hitting when this incident light hitting to the reflecting surface, after hitting this light will retraces its path like this. That one we will observe in the case of when the incident light is incident along the center of the concave mirror. So these are the two important reflections, important cases we will see in the case of a concave mirror. So first case is when the ray of light incident along the principal focus of the concave mirror. So after hitting to the surface, it will bounces back. That reflected ray is always parallel to the principal axis. And another case is that if I incident a light along the center of the concave mirror, after hitting to the reflecting surface, that incident ray will retraces its path like this. Okay, this is the reflection at a concave mirror. So these are the some important terms and reflections at a concave mirror. Now let us discuss the another type of the spherical mirror, that is nothing but a convex mirror. Then what do you mean by convex mirror? Convex mirror also a part of a hollow sphere and whose the reflecting surface is away from the center of the curvature or center of the sphere. Then it is called as a convex mirror. So convex mirror is nothing but it is the part of the hollow sphere whose the reflecting surface is away from the center. Reflecting surface is away from the center of the sphere. Then it is called as a convex mirror. So how to represent a convex mirror? Let us see. We know that so this is a convex mirror is a part of a hollow sphere. So that I am considering one sphere and it has a center. So we already know that if I take this part of the sphere, then I will get the concave mirror. So then I will get the concave mirror. Right. So this is I am considered as a concave mirror. That means so this one is the reflecting surface, another one is the another surface is opaque. Suppose that if I take this part, then this is considering as a convex mirror. Okay. So if I separate this one, I will get the convex mirror like this. So this is the convex mirror and this is the center for this curvature. So this is the one of the part of the hollow sphere and the reflecting surface is away from the center. See, reflecting surface is away from the center. If this one is the center, reflecting surface is far from this center. That means now this one is the outer surface is the reflecting surface and the inner surface is the opaque or it is a painted or it is a non-reflecting surface. So this is the way of representing the convex mirror. So reflecting surface is away from the center of the curvature. Okay. So here also we are using some terms related to the convex mirror. So that is the most of the terms same as that of the concave mirror. So first one is the pole. Pole of the convex mirror. So pole of the convex mirror is nothing but it is the geometric center of the convex mirror. So if I take this one is the convex mirror, exactly center of this mirror, convex mirror is called as pole of the convex mirror. We already know in the case of a concave mirror. Same as that, like that. Here also we are using the pole. That is the exactly center of the convex mirror. That is called as a pole. Next, another term we used, that is nothing but the radius of curvature of the convex mirror, or radius of the convex mirror. Radius of a convex mirror. Radius of convex mirror is nothing but it is the distance from the pole to the center. That is called as the radius of the convex mirror. So distance from a pole to the center, that is the radius of the convex mirror. And this term also we are used in the concave mirror also. Same like that, here also we are using the terms the radius of a convex mirror. And another term we used there, that is nothing but the principal axis. Here also we are using the term principal axis. We know that principal axis is nothing but it is the line joining the center of the curvature to the pole. It is the line joining the center of the curvature to the pole, and that line has no any finite distance. There is no finite distance for principal axis. So that is the principal axis in the case of a convex mirror also. And another term we use principal focus. Principal focus. This is a little different compared to the concave mirror. So principal focus is a little different in the case of this convex mirror compared to the concave mirror. Then what is the principal focus in the case of a convex mirror? So principal focus of the convex mirror is nothing but when a parallel rays are incident, when parallel rays are incident on a reflecting surface of a convex mirror, then they will appear to diverge from a point inside the mirror after reflection. And that point is called as a principal focus of the convex mirror. So when the parallel rays are incident on a reflecting surface of a convex mirror, then they will appear to diverge from a point inside the mirror after reflection. That is called as a principal focus. Now let us see how to represent a principal focus. See, here I am considering convex mirror. This is a convex mirror, and this is the reflecting surface. This is the non-reflecting surface, and the center of this mirror is pole, and this is the center of curvature C. From pole to the center, that distance is called as a principal axis. Now suppose that if I incident ray of light, that is the parallel ray of light. Parallel ray of light means we know that the light rays, it is incident light rays parallel to the principal axis. So I am incidenting one light ray on the reflecting surface of the convex mirror. So when it is hitting to the reflecting surface, then it will bounces back like this. So it will bounces back like this. But this reflected light appear to diverge from a point inside the convex mirror. That means suppose that if I extend this one, incident this ray of light. Take this as center, and I am extending this reflected ray of light. If I extend this line appear to diverge from some point inside the mirror, that is the inside the convex mirror, and that point is called as the focus of the convex mirror. Suppose that if I take another ray of light, that is parallel ray of light, I am incidenting like this. So after hitting to the reflecting surface, it will bounce back like this, and this line or this reflected ray appear to diverge from some point inside the mirror. So that point is a focus. If I extend this one, then I will get a point inside the convex mirror, and that point is called as a principal focus in the case of a convex mirror. Now let us see how to draw the normal in the case of a convex mirror. So normal. So what is the meaning of normal in the case of convex mirror? Normal to the convex mirror, at any point is the line joint that point to the center of the convex mirror. Then it is called as a normal of the convex mirror. We know that normal we are drawing to calculate the angle of incidence and angle of reflection. Then let us see how to draw a normal in the case of a convex mirror. See here, this is a convex mirror. This is the pole, this is the focus, and this is the center of the convex mirror. And we are going to incident and ray of light on the reflecting surface of the convex mirror. When it hits to the reflecting surface of the convex mirror, that incident light will bounces back like this. Then this one is the reflected ray. This one is the incident ray. This one is the reflected ray. Now I want to find the angle of incidence and angle of reflection. To know the angle of incidence and angle of reflection, I am drawing one line. That line is called as normal, and that line should be taken. That line should be drawn from the point at which the incident ray and reflected ray meets on the reflecting surface. That is the point here, and I have to draw one line from that point like this, and that line should pass from center of the convex mirror. That means it should pass through the center of the convex mirror. Then I can calculate the angle of incidence and the angle of reflection. And this one is called as a normal. This dotted line is called as normal. So angle between the incident ray and normal is called as angle of incidence. Now angle between the reflected ray and normal is called as angle of reflection. So this is the angle of reflection, or this is the angle of incidence. Like that we are drawing the normal in the case of a convex mirror. Now let us see reflection at a convex mirror in two different cases. The first case is, suppose that if I incident a ray of light towards the center, okay? If I incident a ray of light towards the center, towards the center of the convex mirror, that means if I incident light, ray of light, and suppose that if it hits us to the surface of the convex mirror, and if I extend this line, then it joins to the center. Then it is called as a ray incident. I am incidenting ray of light towards the center. After hitting to the reflecting surface, then it will retraces its path. That is the first case. That means suppose that if I incident a ray of light towards the center of the convex mirror, then it will retraces its path. That means the reflected ray will retraces its path. That means the path of the incident ray and path of the reflected ray is same. That is the first case. And the second case is, suppose that if I incident a ray of light along the focus. Along the focus means, see here, I am incidenting ray of light like this, and after hitting to the reflecting surface, suppose that if I extend this line and it joins to the focus, okay, it joins to the focus, extend like this, suppose that it joins to the focus, then the ray of light, that means the incident ray of light will bounces back like this. That means the incident ray will bounces back to the medium, and that reflected ray is always parallel to the principal axis. That is in the case of along the, if I incident a ray of light along the principal focus, along the principal focus of the convex mirror. Convex mirror. So, if I incident a ray of light along the principal focus, then the reflected ray is always parallel to the principal focus. Suppose that if I incident like this, I am incidenting ray of light that is along the focus like this. So, after hitting to the reflecting surface, then it will reflect like this. So this one also parallel to the principal focus. That means it is always parallel to the principal focus. Suppose that if I incident a ray of light along the focus. So that is about the spherical mirrors.